Hello folks, we are again back with the next video of this elaborate exercise 6.5. There are so many problems in that. So we are going to take the problem that is to follow question 7. Yeah, question 7. The last video I think we stopped with question 6. So we're going to take the question 7. It's been put on the board. This is your function. I'll read the question. Let's see what it says. Find both the maximum and the minimum value of this given function on the intervals or closed interval 0 to 3. So we had learned about the absolute. When they say only maximum minimum, obviously they are asking us the absolute maximum minimum. So they're telling us to find the absolute maximum and minimum for this particular function on the interval 0, 3. So as we always did, we are going to find the critical point, and whatever critical point that we get, that along with 0 and 3, because they are the endpoints of the closed interval, we will check the function's value at those points, and accordingly we will try to find out which is the maximum and the minimum value. So it's pretty easy actually. So let's call this function as by some name, and that way let's get across doing this. So to begin with, let's call, because it's very difficult to always take the polynomial and do it, so let's call this function as f of x is 3x raised to 4 minus 8x cubed. It's a huge function, it's a huge polynomial. 12x squared minus 48x plus 25. As usual, we are going to take the first derivative, and let's see what's the first derivative. 3x raised to 4, x raised to 4 has a derivative 4x cube, so it's going to be 3 times 4x cube. Then x cube has the derivative 3x squared, x squared has the derivative 2x, 48 times x has derivative 1, and 25, because it's a constant term, there's no derivative. So this is the derivative function. Let's organize it. It will be 12x cube minus 24x squared plus 24x minus 48. So that's your function. It's for us to find out the critical points and then to find the maximum and minimum. So let's, for the critical point, let's call the first derivative function to be 0. Therefore, it is like 12x cube minus 24x squared plus 24x minus 48 is 0. We have to find out what are the critical points here. If we carefully observe, there's a 12 common, I suppose. So let's take that 12 out. So it's like x cube minus 2x squared plus 2x minus 4 equal to 0. The 12 can go on the other side. It's multiplication, it's going on the other side, becoming division, and finally it will get eliminated. So you are left with x cube minus 2x squared plus 2x minus 4. If we carefully observe, we'll be able to factorize this by grouping these two parts. So when we group these two, x squared is common. So x squared times x minus 2 first bracket, and second bracket in these two terms 2 is common. So it's x minus 2. Like that, when we take both these, we'll see that there is an x minus 2 which is common. So let's take that x minus 2 common, and the uncommon term is x squared plus 2 equal to 0. Now we learnt even previously that product is 0, each of them have to be 0. So you will get x minus 2 0 and x squared plus 2 as 0. But this you will not be able to get a solution, no solution, because it is irreducible in real numbers. This of the type, the equations of this type, they are irreducible. If you want, we can just check minus b plus or minus root of b squared minus 4ac over 2a. You will be able to get the root of a negative value, which cannot be found out in real numbers. So therefore that part we will not be able to do. This of course will, so if you want, you can find it by minus b. The b here is 0. See, a here is 1, b is 0, and c is 2. So minus b you need not be bothered, plus or minus b squared you need not be bothered, minus 4ac. 4ac is 4 times 1 times 2. That itself is a negative root. This is the problem. You will not get an answer here. 2a means it's 2. So no real solution. The answer to this is a complex number. It is not a real number. So you don't get it. But this can be solved. You get the value of x as 2. That's enough. So we have the endpoints 0, the endpoint 3, and this 2. All this we'll try to find what is a maximum value. So for that, maximum minimum. So let's find f at 0. F at 0 means to the function substitute 0 and check how it comes. So if the function is going to be 0, it is going to be like it's going to be 3 times 0 raised to 4 minus 8 times 0 raised to 3 plus 12 times 0 squared minus 48 times 0 plus 25. So all this is going to be 0, this is going to be 0, this is going to be 0. Finally, you're going to get 25. So you're getting the function's value at 0 as 25. Let's calculate the function's value at 2. So at 2, the function's value is going to be 3 times 2 raised to 4, 8 times 2 raised to 3, 12 times 2 squared, 48 times 2, and then 25. So that is going to be 16 times 348, 8 times 8 64, 4 times 12 48, minus 48 times 2 plus 25. This 48, and this 48 times 2 will cancel. Otherwise, you can add and find out, it will get cancelled. You are left with minus 64 plus 25, which is negative 14. 14 minus 5 is going to be 9, and 5, yeah, minus 39. That's f of 2. Let's find out f of 3 also. So that is going to be 3 times 3 raised to 4 minus 8 times 3 cube plus 12 times 3 square minus 48 times 3 and then 25. So that is 3 9 81. 3 3 times 9 9 9 times 81, and 81 times 3 is 243. Then this is 27 times 8. So 27 times 8 is going to be 56, 5, 8 and 2, 16, 216. Plus 9 times 12 is 108. 48 times 3 is 8 3s are 24, to carry 12, 144. And plus 25. So check how this is going to be. 243 plus 108 plus 25, and these both are minuses, 216 and 144. So let's see how this is working out. 8 and 3 11, and 5 it's going to be 16. 6 and 1 7, 376, and here it's going to be 10 6 3, so it's going to be 60. So apart from these three values, that is 25, then we have negative 39, and then we have 16. So we have to check which is the maximum and minimum value. It's very clear to us that this is going to be anyhow the minimum, and obviously this is going to be the maximum. So let's check what the question is. Once again, what do they ask us? Let's check the question. The question says that what? Find the maximum and minimum value, they are saying. Okay, they are asking us the maximum and minimum value. Fine. So it is going to be find the maximum and the minimum value. All right, so let us write the maximum and minimum value. The values that we get over here, it's going to be minus 39, negative 39 and 25. So the maximum value is maximum value is 25 at x equal to 0, and minimum value is negative 39 at x equal to 2. Yeah, that's about the values and its maximum and how do you go about it. Though the concept is small, but because the concept is easy, but the polynomial is little elaborate, so maybe it calls for a little more work. That's all. So that's all for this problem. With the next problem, probably we could meet in the next video. Thank you.